Okay, so in the last video, we just talked about what the ideal gas law was, the PV equals nRT, which can be manipulated like any formula. So we're going to look at the problems on page, look at the problems on page 437 to practice the skill that we just talked about. So number 41 says that if we have a pressure that is exerted by a gas at 25 degrees Celsius, okay, and a volume of 0.044 liters, and it's being held at a pressure of 3.81 atm, we want to know how many moles of this gas are present. Okay, so how many moles of the gas? All right, so let's look at our PV equals nRT here and see what we have. We have pressure, the 3.81. We have a volume, the 0.044 liters. We always have our constant, which we can choose, the 0.0821 or whatever, depending on what we have. So we have this. And temperature, we have 25 degrees Celsius, which we can change change with the 273 conversion to Kelvin. So we're looking for moles. We're looking for N. So how am I going to get N alone? To get N alone, I'm going to take PV over RT. These two guys are going to get divided over to give me moles alone. Okay? So we're going to take our 3.81 atm times our volume, which is 0.044 liters, and we're going to do this over the constant. Now, because we have atm, we're going to use the constant of 0.0821, and this is liters times atm over moles over Kelvin. And I know these are annoying to write out these labels, but trust me, you're going to want to. Otherwise, nothing's going to go right. Okay? And then the last thing, we've got Celsius to Kelvin. So in this situation, we're going to add 273 to that. So if we add 273, what are we going to get ourselves? About 298 Kelvin. Okay? So now we're just going to multiply everything on top divided by everything on bottom. So we have 3.81 times 0.044 divided by on the bottom. Make sure you use those parentheses. 0.0821 times 298, right parenthesis, equals, and we end up with 0.00685. Okay, well, we're going to end up with 2 sig figs is the best option we have. So we're going to end up with 0.0069 or 6.9 times 10 to the negative 3 moles of gas. We don't know what gas it is, but that's the gas that we're going to come up with. Okay, so here's one example on page 437, number 41 of manipulating this. Go ahead and try number 42 on the same page and see how you do. And then the next video we'll have the answer to 42, and then we'll actually take you on to a new way to manipulate the ideal gas law.